Okie dokie, here we go. Key to your review. So, we've got the graph of the function f is shown above. Which of the following statements about f is correct? Okay, so they're asking about f. My graph is f. It says f is increasing at an increasing rate, or decreasing at an increasing rate, and so forth and so on. So it's asking me two different things. Those of you that get mixed up with this part of the question is talking about the graph itself. This part of the question is asking about the rates, or the rate of change. Okay, so one thing that helps here is the fun chart. And I've been writing different things here because I don't want to put ROC for rate of change. I put S for slope, but then I realized we say rate all the time, so I don't really care what you put as long as you know what it is. I think I put R or S on your notes, but I think I've decided I like R. I've changed it a bazillion times until I can get my mind wrapped around this. As long as you know it's the rate of change, it's the slope, it's whatever. They're all the same thing. So here's my fun chart that's going to help me. So first of all, when I'm looking at this part here, which is about the graph itself, I look over here, going from left to right, my y values are decreasing as I go along, so that the graph is f is decreasing, so I can mark out those, okay? And then I want to figure out about the rate. Two different ways I can do that. I can draw myself little tangent lines like this, and say, all right, well, that is a negative slope, and it's getting closer to 0. So a negative getting closer to 0 is increasing. I can also look at this as this is concave up, therefore the rate is increasing. So f is decreasing at an increasing rate, and my answer is C. All right, so let's look at G. So it says the function of G is increasing. So again, this is talking about the graph itself, and this is also talking about the graph. So they're both talking about the graph. I don't even need my fun chart, okay? The function G is increasing. I can see that, so I can eliminate C and D, and it is concave up. That's A. All right, so the logarithmic function defined by h of x, which of the following statements is true? So ignoring the negative, this part, we know what the natural log looks like, then it's going to reflect in the x-axis, so this is what it looks like, right? And so then I can separate these up again. The function is decreasing, so the function, this is the graph itself, or the function itself, and the graph, again, is concave down. So, or concave up or down. So I don't need the fun chart. We're not talking about rates anywhere. So I can see that this is decreasing. So those get eliminated. And it is concave up, which makes this C. Okay? All right. Next page. Got a graph again. There's a whole bunch of these because these answer choices are all kind of worded differently. So we've got K here. So the rate of change of K is positive or negative and increasing or decreasing. Both of these are talking about the rate, okay? The rate is this and this. Neither one of them are talking about the graph itself, but I need the graph. So my fun chart, put rate there. Okay. So then my fun chart here, the rate of change is positive. If I want to, or positive or negative, that's what I'm trying to figure out. So if it's between positive and negative, it has to do with the graph, this being the graph here, being increasing or decreasing. Well, the graph is decreasing, so since the graph is decreasing, the rate is negative, so I can eliminate those two. And then this is concave up. Since it's concave up, the rate is increasing, so my answer is C. Number 5, which of the following could be the equation? All right, well, I clearly see here that I have an asymptote here, and that this would be a log graph, not an exponential graph, so I can ignore those two. My parent function of a log looks just like this with no reflection, so my answer is A. right, number 6. I've got this log function. Which of the following pairs of statements in behavior? Okay, so my graph, okay, ignoring, I know what it looks like when it is just a regular old log. The 3 doesn't affect my nasty little sketch. This negative is going to reflect it in the x-axis, so it's going to look something like that. So that means then that the limit as x approaches 0 from the right, so as I'm going to the right here, I can't go all the way to infinity, or negative infinity rather, so both of those are out. I'm approaching 0 from the right, and I'm going to infinity, so I like that one. I better double check that the rest of it's good just in case, but I'm pretty sure I want to mark out A. The limit as x approaches infinity, we're going to negative infinity, so yes, it is B. All right, number 7. So I apologize for the spacing here because this graph does not go with number 7. It goes with number 8, and I messed up on the spacing there. So we'll just ignore the graph while we look at number 7. All right, so we have this graph. Which of the following gives the domain? So I'm looking for the domain, which means I need a little sketch. Okay, so let's think about just the parent function of the natural log. So if I just had natural log of x, it's just going to look like this, right? This 2 is a vertical dilation, but it's not going to affect my little sketch because we're not being exact here. And neither is this minus 5 because that's going to shift it up. But again, you're not going to be able to tell if I shifted it up 5 on here. But this does make a difference. That means that I go to the left 3. I'm sorry, no, it doesn't. It means I go to the right 3. And so I end up over here. But what's important for me for my domain is to know where my asymptote was. My asymptote on the original one is at 0. If I move to the right 3, then my asymptote is now here at 3. So that means my domain goes from 3 to infinity, which is C. All right, so then 8 with the graph that's way up there. So here again, we can split these up. The function is decreasing, so this is the graph. And the rate is doing something else. It's not increasing, it's increasing or decreasing is what I meant to say. So if I'm going to have to if I'm going to have to figure out something for the rate, I need my fun chart. Rate. Okay. So here we go. The function is decreasing, so I can eliminate A and B. And then the rate of change, it's either increase, my rate, if I want to know if it's increasing or decreasing, that's based on whether or not the graph is concave up or down. This one is concave down, so my rate is decreasing. So the function is decreasing at a decreasing rate. It's another way to say it. All right, log function. So here when we split these up, this is the function. So this is my graph and my graph. So I don't need my fun chart. I just need to know how to look at my graph and how to sketch that. So this would be a vertical dilation. It's a vertical compression, but again, doesn't affect my little sketch here. So it's really just log of x. It looks like that. Okay. So this function is clearly increasing. So I can eliminate C and D, and it is concave down. So my answer is B. All right, 10. The values of function k are shown in the table above. Determine if function k could be linear, exponential, or logarithmic. So notice neither is not an answer here, or none of the above. So when I look at what's happening here, those are not changing at equal lengths. So here, each time it's being multiplied by 3. Here, we are adding a -2. Okay? So since my x inputs are not over equal length input value, or equal length intervals, my inputs are they're changing multiplicatively, then that makes it logarithmic. So I can say that k could be logarithmic because the x values are multiplied by 3. Or we could say that they are proportional, multiplied by 3, and y values, or output values, are equally spaced, something to that effect. You don't have to be all fancy like the answer choices are sometimes, but you do need to know what the answer choices are, especially if they word them in weird ways like we talked about today. Okay? So let's look at 11. So this is my function here. This is natural log. That 3, when I do my little sketch, doesn't really affect my sketch, and I don't have to have exact points here. There's no reflections, there's no translation, so it just looks like that. And the only one that looks like that is A. 12, log function. This is a natural log. Remember, don't be afraid of natural logs. We basically just graphed it right above it so we know what the graph looks like. And we have to do our limits. So the limit as we go to the left, I cannot make it to negative infinity, so I can eliminate C and D. I'm definitely going to 0 from the right. As that happens, I'm going to negative infinity. And then as x approaches infinity, f of x goes to infinity. So the answer is A. So then we jump from 12 to 15, the first 15, and there was questions about the numbering. Look, when I piece these things together, sometimes it is very hard to get the numbers to act correctly in the way I have to edit this stuff, and it really doesn't matter, so that's not something I choose to waste my time on. So I just have to get over it. All right, so here is I got this function, I got to do the limits again, and so I know what the parent function of a log looks like that, but in this 1/3, it could still be that, but that negative makes it look like this. So this is what I'm looking at. Again, when I go to the left, I'm not making it to negative infinity, so I'm going to 0 from the right. As I approach 0 from the right, I'm going to infinity. Just going to double check this one. As I go to positive infinity, I'm going to negative infinity. So my answer is B. All right, G. Which of the following statements about G is correct? Okay, so here's another one where we got to see what's happening here. This is talking about the graph that they didn't give me. And this is also talking about the graph. So I don't need my fun chart, but I do need the graph. And this right here, that vertical dilation, not going to change any of these answers, and it doesn't change what my sketch looks like that. So I can see here that my graph is increasing. So the function G is increasing, so I can eliminate those two. And it is concave down, so my answer is B. Okay. 22. Logarithmic function is defined by this. Which of the following statements about f is correct? Okay. So f is either increasing or decreasing, so this is the graph. This at an increasing or decreasing rate, this is the rate. And it kind of says it right there for you. So I'm going to need not only my graph, but I need my fun chart. So this graph, remember natural log just looks like a regular log, but it's reflected, so it's going to look like this. My fun chart, that's my rate. Okay. So then I have, so I can see here that f, my function, my graph is decreasing, so I can eliminate A and B. And this, if I want to know if the rate is increasing or decreasing, I look at whether or not it's concave up or down. This is concave up, so my rate is increasing. So the function is decreasing at an increasing rate. And to kind of re-explain that, because I had some people ask me about that, think about what does it look like when it's decreasing at an increasing rate? Well, clearly this is decreasing, right? But then if I draw in my little things here, this is a slope and then negative slope, but the negative slope is getting closer to 0. So if you have a negative numbers that are getting closer to 0, they are increasing. And these slopes of these lines is our rate. So we're decreasing at an increasing rate. All right, now let's look at 23. I've got this defined here, and so G is increasing, so this means the graph. at either increasing or so the graph is either increasing or decreasing, and then the rate is either increasing or decreasing. So once again, I need the graph and I need the fun chart. So my graph, I've got no reflections. The 3 doesn't affect my little sketch here. And then my fun chart. Okay. And so the graph itself is increasing, so I can eliminate C and D. And then the graph is concave down, therefore the rate is also, or not also, but the rate is decreasing. So this is increasing at a decreasing rate. Okay. Here, function g. So the function g, this is the graph, and the rate is the rate. So I'm going to need the graph and the fun chart. Natural log of x, natural log of x. Okay. Fun chart. The more you write it, the more you will just know how to slap it down quickly when you need it. All right, so the graph itself is increasing. So I can eliminate A and B. And then the rate, I want to know if the rate is positive or negative, or actually no. Positive or negative was here. This is increasing or decreasing now, but we'll go ahead and talk about these also. So the function is increasing, and then the rate, since this is concave down, is decreasing. But if it had asked us, I'm surprised that these two aren't the same right here, but if it asked us the function of g is decreasing and the rate is, if it was increasing and then it said positive or negative here for these, I mean, you can just sketch this on here and see what it is, but because the graph is increasing, that tells me that my rate is positive. So if that was part of the answer choices, then that's how I would know for that. Okay, still from the fun chart. All right, so here's another one. So we're, again, trying to get a whole bunch of these so they say different things and for you to feel comfortable with them. I've got the function, the function, so this is the graph, and then the rate. Heard a lot of good discussion about all this stuff here. So let's see, my graph. This has a reflection in the x-axis, looks like that. I'm going to write my fun chart. Oops, that's not right. Okay, so the graph I can see is decreasing. So it's either A or B. And then I want to know if the rate is increasing or decreasing. That's based on the concavity. This is concave up. Rate is increasing. So the answer is A. Then we have the rate is either positive or negative. So that's the rate. And either decreasing or increasing. This is also the rate. But I still need the graph to be able to figure this stuff out. So log graph, the 3 doesn't really affect my little sketch here. Do the fun chart. Oops, rate. Okay. So whether the rate is positive or negative is based on whether the function is increasing or decreasing. It doesn't ask me this on the answer choices, but the function is increasing. So since the function is increasing, that means the rate is positive. So I can eliminate C and D. And then whether or not the rate is increasing or decreasing is based on concavity. This is concave down. Therefore, my rate is decreasing, and my answer is B. Okay. 34. All right. So we got another one of these where the rate and the rate. Right? Both of these are being asked about the rate. Sometimes you're asking about the graph both times. Sometimes it's a mixture. But I still need the graph. This is the log graph that has a reflection, so it looks like this. All right. So The rate, whether it's positive or negative, is based on whether the function is increasing or decreasing. This function is decreasing. Since the function is decreasing, the rate is negative. So I can eliminate A and B. Whether or not the rate is increasing or decreasing is based on whether the function is concave up or concave down. Function is concave up, rate is increasing, so my answer is C. All right, 14. Now, this is one of those where I know you don't love the wording. I don't love the wording either, but it is what it is, and you have to learn, not learn, but employ the things that your English teachers have taught you about how to read wordy stuff. Okay, so when I look here is what's happening with my x's, because this is asking me which one of the statements, and so I have to decide if it's logarithmic or exponential, and then why. So my x values, I'm just adding 3 each time. My y values are being multiplied by 2. So that tells me it's exponential, so I can knock out my logarithmic, okay? And it's exponential because the outputs over consecutive equal length input value intervals are proportional, or because the inputs over consecutive equal length output intervals are proportional. So let's think about what's equal length and what's proportional. This is equal length, this is proportional. So my inputs are equal length, consecutive equal length input values, and my outputs are proportional. So remember, that's different than what we wrote in class, but that doesn't mean that you couldn't have answer choices that looks like what we wrote in class. You have to understand however they want to say it, still all means the same thing. So we did this one today in class to talk about that, but I'll do it again anyway. So same thing, I got to figure out first if it is logarithmic or exponential. So when I look at this here, this is being multiplied by 1/3. This here, we are adding 2. So since my x's are proportional, then that means that it has to be logarithmic, so I can knock that out. And so h is best modeled by a logarithmic function because the outputs over consecutive equal length input value intervals are proportional, or because the inputs over consecutive equal length output are proportional. Well, we can see here that it's our inputs that are proportional. Our answer is B. Alrighty, we're going to use this graph for 16, 17, and 23 because I took questions out that I didn't want to use. All right, the graph of the piecewise linear function, f is shown above, 3 linear segments. Values of g and h are shown in the tables above at selected values. Let f inverse and h inverse represent the inverse functions for f and h. That's nice. All right, so I want to find h inverse of 2. So h inverse of 2. That means I go to where h is. Instead of looking at the x values, I look at the y values. Here's 2, so h inverse is -1. F inverse of 2, so that's coming from the graph. So F inverse of 2, instead of going to 2 on the x, that's usually our input, and looking at that, I want the inverse. So that means I look at the y value of 2, figure out what my x value is, which in this case is 0. Okay. Then 23, L is defined by this function. Find the value of L of 2. Okay, so L of 2 is equal to F inverse of H of 2. Okay, so let's find, we work from the inside out. H of 2 is -2, so that means I really want F inverse of -2. So then I go to my graph, and I don't go to -2 on the x-axis because that is because this is the inverse, so I want got to use the y value. So -2 is my y value, that makes the x value -4. Alrighty. Now we're going to find the inverse. Just straight up find the inverse. In order to find the inverse, we're switching x and y. So that's my y, basically. Switch them. I'm going to get, that one won't write y again. It's going to give me x equals 4y minus 7. So that means x plus 7 equals 4y. So x plus 7 over 4 equals y. So F inverse of x is equal to x plus 7 over 4. All right, so same thing, going to make that y, and we're going to switch them. So x is equal to 2y plus 7 over 3y minus 4. First thing I'm going to do is multiply both sides by this denominator. So that's going to give me x times 3y minus 4 equals 2y plus 7. Then I'm going to distribute on the left-hand side and get 3xy minus 4x equals 2y plus 7. Then I'm going to get all my y terms on the left-hand side. So 3xy minus 2y equals 4x plus 7, or 7 plus 4x is fine. Factor out a y, and this gives me y times 3x minus 2 equals 4x plus 7. Then I can divide, so y equals 4x plus 7 over 3x minus 2, which means that G inverse of x equals 4x plus 7 over 3x minus 2. All right. Number 3. Make that y. So x equals y minus 2 over 6y plus 4. Multiply both sides by the denominator. So I get 6xy, that's not a y, y plus 4x equals y minus 2. Get all my y's on one side, so 6xy minus y equals negative 2 minus 4x, or negative 4x minus 2, doesn't matter. So y equal, no, not y equals, I'm going to factor out y times 6x minus 1 equals negative 2 minus 4x. Then I divide. Negative 2 minus 4x over 6x minus 1. So that means that H inverse of x is equal to negative 2 minus 4x over 6x minus 1. So one thing that might be helpful to know about these kinds of questions is that the signs in my answer could look different if I chose, like instead of moving my y's over to the left here, if I move them to the right, then my answer would look different, but it would have the same value. And that actually could come up in a multiple choice question. Like maybe you get this and you know you did it right, but that's not what the answer choices are. So at any time you have, like I have no parentheses or anything weird going on here, but this is also equal to the same thing if I change the sign on literally everything. If I made this 2 plus 4x over negative 6x plus 1, it's the exact same thing. And of course, if they were flipped around like 4x plus 2 and 1 minus 6x, all that would be fine. I don't know that that would necessarily happen to you, but I guess it could, because right here, nobody's telling you how you have to go about putting your stuff on which side. Okay. All right. Number 5. So it says determine the end behavior. So end behavior means as x approaches infinity, or as x approaches whatever we can approach. And then here's what I did wrong on the answer key. I just put the limits of both sides. I don't need to put the limits of both sides. We'll go ahead and talk about them, but then I'll tell you why we don't need both of them. First of all, because it just says as x increases without bound. It doesn't say all the end behaviors. And it says express your answer using the mathematical notation of a limit. So the first thing I need is a little sketch here. So this is what it looks like, and I know what the log looks like. It reflects, it looks like this. So I'm going to, like I said, I'm going to go ahead and write both limits. So I know that my left-hand limit, that's the limit as x approaches 0 from the right of L of x. So as I approach 0 from the right, I'm going to infinity. And then my right-hand limit, the limit as x approaches infinity of L of x, is equal to negative infinity. But that would actually be the wrong answer, because if I just do both willy-nilly because, okay, they're not wrong, but if that, then I don't know if you know what this means. What that means is this right here, so this is actually not part of the real answer. Like, that's a correct answer, but not what this question is asking. So just read the question better than I did, and I put it on here, so. All right, so we've got f be decreasing function, and so they told me it's decreasing, plus I can see that it's decreasing. The table gives values for f of x. The function g is given by this right here. Okay. So function h is defined by g of f of x. Find the value of h of 0. Or indicate that it's not defined. Okay, so h of 0 will be equal to g of f of 0. Okay, so f of 0 is 8, so that's equal to g of 8. And then g of 8, well, this is g, so this would be log base 2 of 8. Okay, but I can find the actual value that does not have a log in it. And some people asked me about what I had on the answer key because I used a z. I chose not to use x because x is being used all around here. But basically, I wanted to see, can I find an actual value for this? Like sometimes we can't and we have to use the calculator. But I'm going to see if I can. And maybe I shouldn't have put it all in one thing. So I'm going to come over here and say, all right, well, let's say that log base 2 of 8 is equal to, I used z. I don't know why, but z. So when I rewrite that, it'll give me 2 to the z power equals 8. And then I got to ask myself, what power do I take 2 to get 8? That answer is 3. So that means not only does z equals 3, but log base 2 of 8 equals 3. So my answer is 3. Now, just like off the top of your head, like, should you know what the square root of 9 is? Boom, it's 3. Yes. Should you know what log base 2 of 8 is right away? Maybe not. And there's actually another way to go about finding it based on what we learned in class today, but we'll talk about that later because I don't want to confuse things. All right. I want to find the value of f inverse of 4. So f inverse of 4, or indicate that it's not defined. So here are my f values. Instead of taking this 4, I look at this 4, and the f inverse of 4 is 1. Okay, so determine the end behavior of g as x increases without bound. Express your answer using the mathematical notation of a limit. So this time it just says the end behavior. It doesn't say, oh no, it does again. Oh, look at that, as x increases without bound. Well, helps if I actually read the question. Apparently I did that one wrong too. Good Lord. But you do need to be able to write both limits. Let me just throw that out there. But this time I'll just do this one. So let me look back up here. What did g of x look like? G of x, it's log base 2 of x. So log base 2 of x just looks like this. And I want this as x increases without bound. So that means that's the limit as x approaches infinity. That is increasing without bound of g of x equals, and from my graph I can see that is infinity. All right, then use the table of values to determine if f is best modeled by linear, quadratic, or exponential, or logarithmic. Okay, so I'm going to go back up here, and let's see what's happening here. Now my x values, these are all being, we're just adding 1, right? My y values, we are being multiplied by 1/2. So, go back down here. Use the table of values, best modeled by linear, quadratic, exponential, or logarithmic. So that was, oh my God, I scrolled and I already forgot what I had up there. This is exponential, right? So my answer here is exponential. And I instinctively just wrote out my reason why without realizing that didn't say explain. And then the second little bullet here says, give the reason for your answer based on the relationship. Okay. And since it's worded like this with the change in the output and the change in the input, I would, just to be safe, go ahead and use those words instead of x and y, because y is not even up there. It's f of x. So I can say, I don't want to say this. F is best. Well, I guess I don't have to repeat the exponential part. I was trying to decide what to do here. So we can just give the y. So my output values of f, I could say change multiplicatively, but I could also say output values of f are multiplied by 1/2. Input values of f are equally spaced. All right, last part here. Lots of words, but you're going to have to deal with lots of words. So students who completed a class participated in a year-long study to see how much content from the class they retained over the following year. At the end of the class, students completed an initial test to determine the group's content knowledge. At that time, t equals 0, the group of students achieved a score of 75 out of 100. For the next 12 months, the group was evaluated at the end of each month to track their retention of the content. After 3 months, t equals 3, the group score was 70.84. All right, so the group score can be modeled by this function R, where R of t is the score in points for month t, and t is the number of months since the initial test. So this first part says, use the given data to write 2 equations that can be used to find the values for constants a and b in the expression for R of t. All right, so when you read that, think about what it's asking you to do, what it literally says to do. It says, we're going to use what they gave us. We don't have to figure anything out. We are going to write 2 equations that can be used to find the values for a and b. Does it ask me to find the values of a and b? The answer to that is no. So there is nothing difficult about this. Did we do a question exactly like this? No. But should you be able to figure out what the heck is going on? Absolutely. Because I have 2 ordered pairs. I have the ordered pair 0, 75, and I have the ordered pair 3, 70.84. And all of these are t, comma, R of t. That's how it works. It's just an equation. So when I go to do this, I need to find a and b. So I need a and b to be my only variable. So I'm going to use my ordered pairs. R of t, if I use 75, that's going to be a plus b times the natural log of, and so if I use 75, I got to use for t 0 plus 1. And my other one would be 70.84 equals a plus b times the natural log of 3 plus 1. You do not have to do anything else. That is it. Now we could, but we're not going to. It's not necessary right now. We don't need to. Then it says to use the data to find the average rate of change. So I know that average rate of change, this just means slope, per month from 0 to 3 months. Express your answer as a decimal. This is what I was talking about today in class. It's not going to be pretty when we're done, and that's totally fine. To show computations. Okay, so every single time you start one of these, don't just start plopping all the numbers in, right? We're going from 0 to 3, which means we need R of 3 minus r of 0 over 3 minus 0. Then I substitute in what r of 3 is. R of 3 is 70.84 minus r of 0, which is 75, over 3 minus 0, which is 3. Now, when I subtract those, which you totally should be able to do, you're going to get negative 4.16 over 3. That does not divide evenly. That is totally fine. We're just going to leave it like that because this would either be something that I would allow you to, or you would be allowed to use a calculator for, or the numbers would be prettier if it wasn't. But I took out a lot of this question, so we're not doing having the calculator stuff in there anyway. All right, but I do need to interpret the meaning of your answer from this one in the context of the problem. All right, so what did they tell us to find? It's the average rate of change. So I can start with the average rate of change of what? Of the student scores Okay, so the average rate of change of the student scores. Not forever and ever, amen, not for any, any time you want to think of. The average rate of change of the student scores from t equals 0 to t equals 3. Don't forget your units, months, is negative 4.16 divided by 3 points per month. Now, had you said something like the average rate of the student scores are decreasing at an average rate of, if you throw that word decreasing in there, then this would have to be positive because you can't, decreasing and negative is like a double negative. But this is what's happening. The average rate of change, this is it. That is interpreting it in the context of the problem. All right. So then it says to consider the average rates of change of R from t equals 3 to t equals p months, where p is greater than 3. Are these average rates of change less than or greater than the average rates of change from t equals 0 to t equals 3? All right. So when I look back up here, I know this function is a log function. I know that since we didn't find A and B, it could be positive or negative for all I know when I'm just glancing at this. And A is not going to affect a crazy little sketch that I have, but B might. But at least I know if it's a log, it's either going to look like this or it's going to look like this. Okay? And here's how I can know for sure. When I come over here and I'm going to draw myself a little sketch, and it's going to be just a teeny tiny bit more detailed than the others. I know this is 0, this is 3, and P is somewhere here bigger than 3. And so if I know what some ordered pairs are. I have the ordered pair of 0.75, and I have an ordered pair of 3.70. So if I have those 2 points and I know what a log looks like, it's going to look something like that. Okay? So that's all I really need to know at this point. So from here to here, so consider the average rates of change of R from t equals 3 to t equals blah, blah, blah. Are these average rates of change less than or greater than the average rate of change? All right, so from 0 to 3, there's that rate of change. From 3 to p, whatever it is, and whatever's in between there's that rate of change. So from what we know, and from even the fun chart that could help you here, fun chart, if you need to, rates. Okay. So this here, the graph is concave up, therefore the rates are increasing, right? So the rates are increasing, so that means that they're going to have to be greater than the rates from before. And so that I can say so the average rates of change, and there's not a whole lot of room here, but average rates of change from t equals 3 to t equals p months, and I'm just getting those words directly from the question, would be greater than from t equals 0 to t equals 3 months because R is concave up therefore the rates of change are increasing. Now, they're slowing down, but they're increasing because you have a negative number that's going to a positive number. Okie dokie. Let's look at these last few. So these, if I look at 1, 2, and 3, I'm not solving for anything. It says rewrite. We literally just rewrite. The base of the log is the base of the exponential. That's my exponent, 2 to the 6th equals 64. True statement. Base 4 to the negative 3rd power is equal to 1 over 64. Then 25 to the 3/2 power is equal to 125. Let's think about, just take a little side trip with me here. And let's think about what this, because this we should be able to figure out, like even if they didn't tell me it was 125. 25 to the 3/2 power. That's the same thing as taking 25 and cubing it, then taking the square root, or taking the square root and then cubing it. So it would be like the square root of 25 cubed. And I can decide, do I cube 25 before or after I take the square root? I'd say after. Square root of 25 is 5. You cube it, you get 125. All right. Rewriting this as logarithms. So the base of the exponential is the base of the log. This is log base 10, so I don't even need that. Log of 1,000 equals 3. This would be log base 16 of 1024 is equal to 5/2. Once again, I have a log base 10 of 1 over 100. That's equal to negative 2. All right, and then now without a calculator, I'm finding the actual value. So I'm going to set this equal to x, and then I'm going to rewrite it. 5 to the x power equals 625. So you can use your fingers. 5 times 5 is 25, times 25 is 125, times 5 is 625. So that is 5 to the 4th. So x equals 4. I'm going to set this equal to x. And then, so that's going to be 10 to the x power equals 100,000. All right, so 10, 100,000, 10,000, 100,000, that's 5. So x equals 5. Oh, I just realized this last answer isn't even on the answer key. That's okay. Equals x, so 27 to the x power equals 81. Well, that one's not quite as straightforward, but I can get congruent bases. I can get the same base. So 27 to the x power, well, I know I've got 9 times 3 is 27, but I can't like split it into a 9 and 3, but I can make it 3 cubed. No, that's 3 to the 3x power, right? Equals, and then 81, so 3 times 3 is 9, times 3 is 27, times 3 is 81. So that would be 3 to the 4th power. And if those two are the same, then 3x equals 4, x equals 4/3. Okay? Because I could take, because to get from 27 to 81, I'd take the cube root and get 3, then take it to the 4th power and get 81. Okay, so make sure that you are prepared for your test tomorrow. Remember, you're also going to have to fill in the first quadrant of the unit circle, and you have worksheets you got to turn in. If you're not sure which ones, the calendar is in Schoology. Not only you have to turn in worksheets, but your digital assignments have to be done as well. And the 0.8 and 0.9 are not on the test, but you do need to turn those worksheets in. They still have to be done. Don't give me any sad, sorry excuses. So get that stuff ready to turn in. I'll have staplers for you so you can staple them all together. Please have them in order. And then you also have Delta Math stuff that's supposed to be done. So hopefully you've been keeping up with it. That was my goal in all of this, so that you actually know this stuff and you are prepared. If you find yourself without a worksheet that you should have done, that stuff is in Schoology as well. All of the digital copies of anything that I have given you is in there. So you can print them out. If you don't have a printer, you can write it down on a separate sheet of paper, but get your stuff taken care of.